In this chapter, we're going to explore how we can move beyond just basic prompts and start building some truly powerful applications on top of large language models. We're going to take a standard LLM and really unlock its potential, turning it from a simple text generator into something much more capable.
So when you think about a large language model, what comes to mind? For a lot of people, it's a simple chatbot, right? And while that's a great starting point, it's really just scratching the surface. The true power of these models gets unleashed when we start plugging them into bigger, more complex systems.
And that's exactly what we're going to do. We're going to give our LLM 3 major upgrades. First, a structured workflow to guide what it does. Second, a memory so it can actually remember past interactions. And third, a set of tools so it can interact with the outside world. This is where we go from chatbots to truly intelligent applications.
So here's our game plan. First, we'll talk about why we need to move past simple Q&A. Then we'll dive into the concept of chains, which is how we'll give our LLM that workflow. After that, we'll add memory, which is absolutely crucial for real conversations. And finally, we'll look at agents. This is how we give LLMs tools to get things done on their own.
Look, being good at prompt engineering is a super valuable skill, but it has its limits. If you want to build robust, real-world applications, you have to think bigger than just a single prompt. You need to build entire systems around the LLM, and frameworks like LangChain give us all the building blocks we need to do that.
So the first problem we run into is just managing the prompts themselves. Some models, a good example is Microsoft's Phi 3, are really picky about their prompt format. They need these special tokens, like unique markers in the text, to know where the user's question starts and ends, and where the AI's answer should begin. Having to do that by hand every single time, it's not just a pain, it's also super easy to mess up. This is where we really need some automation.
And that brings us to our first really big idea, chains. Chains are the perfect solution to that automation problem we just talked about, but they do so much more. They let us give our LLM a structured workflow, linking different parts together in a sequence that's both predictable and efficient.
So what is a chain exactly? Well, you can think of it like an assembly line for our AI. The user's input comes in at one end. The next stop is a prompt template that automatically formats that input perfectly for the LLM. Then it gets passed along to the LLM to do its thing. Each one of those steps is like a link in the chain.
And here's what that basic workflow looks like. You've got the user input, like a question. The chain then grabs our pre-made prompt template and applies it to that input. And finally, that nicely formatted prompt gets sent off to the large language model. It's a simple process, but it completely automates all that manual formatting we wanted to avoid.
But we can take this idea way further. Let's say you want to generate a full story. Instead of trying to cram everything, the title, the character, the summary, into one huge complicated prompt, we can use what's called a sequential chain. This breaks the big task down into smaller, simpler steps. The first chain just generates a title. Then that title gets fed as input to the second chain, which creates a character based on it. And finally, the title and character description are used by a third chain to write the summary. It just gives you so much more control, and the results are way more reliable.
So the key takeaway here is that chains are way more than just a formatting trick. They let us design these complex, multi-step processes. By breaking down a big task into a series of smaller, specialized subtasks, we can get much more predictable and higher quality results from our LLM.
Okay, so we've given our LLM a workflow. Now let's tackle another huge limitation, its memory. Or, well, its lack of memory. Without the ability to remember what was said just a moment ago, you can't really have a proper conversation. Let's figure out how to fix that.
The problem, fundamentally, is that LLMs are stateless. All that means is that every single time you interact with it, it's a completely fresh start. It has no memory of what came before. It's like having a conversation with someone who has zero short-term memory. It makes any kind of real back-and-forth dialogue totally impossible.
In this example shows it perfectly. Without memory, you say, "My name is Martin," and it says, "Hello, Martin." Great. But then if you ask, "What's my name?" it has no idea. But once we add a memory component into our chain, the model can look back at the conversation history and give you the right answer.
Now, there are a few different ways to actually implement memory, and each one has its trade-offs. The simplest is the conversation buffer, which just keeps everything. The pro is you don't lose any info, but the con is you can run out of memory, or tokens, really fast. A windowed buffer is a nice compromise. It only keeps the last few messages. And then there's a conversation summary, which actually uses another LLM call to create a running summary of the chat. It's concise, but can be a bit slower. Which one you choose really just depends on what your application needs.
All right, we've given our LLM a workflow using chains and a memory for conversations. Now it's time for the final and, I think, most powerful piece of the puzzle, agents. This is where the LLM stops being a passive tool and starts becoming an active decision maker.
And this question right here is the whole idea behind agents. With chains, we, the developers, had to define the exact sequence of steps. But with agents, the LLM itself looks at a problem and figures out the best way to solve it.
So, an agent is basically a system that uses an LLM as its brain or its reasoning engine. Instead of just spitting out text, the LLM thinks about the user's goal, looks at a set of tools it has available, like a search engine or a calculator, and then it comes up with a plan, deciding which tools to use and in what order.
A really popular way to build these agents is with the REACT framework, which stands for Reasoning and Acting. It works in a simple loop. First, the LLM has a thought, where it figures out its next move. Based on that thought, it takes an action, which means picking a tool and using it. Finally, it gets an observation back. That's the result from the tool, and it uses that new piece of information to start the cycle all over again with a new thought.
Let's walk through this example. A user asks for the price of a MacBook Pro in euros. The agent's first thought is, okay, I don't know the price in euros, but I can probably find it in US dollars first. I'll use my search tool. So its action is to search for MacBook Pro price USD. The observation comes back, the price is $2,249. Now it has a new thought. Okay, I have the price in dollars, now I just need to convert it. I'll use my calculator tool for that. And its action is to use the calculator. This kind of step-by-step reasoning is what lets an agent solve complex problems that a normal LLM just couldn't handle on its own.
And this really is the bottom line. With agents, the LLM isn't just a passive machine that answers questions anymore. It's an active problem solver that can use tools to achieve a goal. It's a massive shift in what these models can do.
Of course, this power comes with its own challenges. When you give an LLM this much autonomy, you're also giving up some direct control. An agent might pick the wrong tool, or it might misunderstand a result. So building reliable agent systems means you have to think carefully about things like error handling, and maybe even having a human check its work.
So as we wrap up, the biggest thing to remember is this. An LLM's true potential is unlocked when you use it as the reasoning engine at the center of a larger system. Its ability to understand language and plan is what lets it use all of these other tools we can give it.
Let's do a quick final recap. We started with chains, which are the building blocks for creating automated workflows. Then we added memory, which is what lets us have real, stateful conversations. And finally, we explored agents, which turn the LLM into a reasoning engine that can actually use tools to solve problems in the world.
And that leaves us with one last question for you to think about. Now that you know you can give an LLM its own custom toolbox, whether that's for searching the internet, analyzing data, or even controlling other software, what kind of really complex, real-world problems could you start solving with it?